In this lesson, you'll learn how to multiply rational expressions. How can you multiply rational expressions to determine the cost of electricity? There are 25 lights around a patio. Each light is 40 watts, and the cost of electricity is 15 cents per kilowatt hour. You can use the expression below to calculate the cost of using the lights for each hour. I set it up carefully so that the 25 lights would cancel out with the 40 watts per light, and the watts cancel out with the 1 kilowatt per 1,000 watts. And the cost was 15 cents per kilowatt hour. And the kilowatts happen to cancel out there as well. And we know that $1 is the same as 100 cents. When I type that in the calculator, 25 times 40 divided by 1,000 times 15 divided by 100, I got 15 cents. The multiplication expression above is similar to the multiplication of rational expressions. Recall that to multiply rational numbers expressed as fractions, you multiply the numerators and multiply the denominators. You can use the same method to multiply rational expressions. Now, with the example printed in your book, they multiplied everything out and then worried about dividing out the greatest common factor. I think I prefer the second method, which is to divide by common factors before multiplying. So I can see 7 and 7, well, and 7 again, and 2, and then we can worry about our variables. I can cancel out a factor of x, I can cancel out a factor of y, and a factor of z. So all that I have left in the numerator is 1 factor of x, and in the denominator I have 6z squared y cubed. So again, we can start by canceling a factor of 5, a factor of 6. That's all I can do for the numbers. Now I can start tackling the variables. Oh, both of my c squares are going to cancel out. Anything divided by itself is exactly 1. The d to the 4th will cancel with d squared, leaving a d squared in the numerator. The q cubed cancels with the q to the 5th. Power divided by power, we subtract exponents, so I have q squared. And r cancels with r to the 4th, so now I have r to the 3rd. So in the numerator, I've got a d squared, q squared, and r cubed left. Over the denominator, looks like all that's left behind is 18 times 2, which is 36. If we want to multiply, it would be nice to have that second expression factored first. So I need factors of negative 32 to give me a sum of negative 4. So I could do negative 8 and positive 4. And now I can see the x plus 4 will cancel out. I can cancel out a factor of x. And then we're done. All that I have left in the numerator is x minus 8, and the denominator is x squared. And in this lesson, they didn't make us state the excluded values, so we're done. The first numerator can't be factored, but I can factor the denominator. Greatest common factor is 4. In the second fraction, I need factors of 3 to give me a sum of negative 4. So I want negative 3 and negative 1. And then I need factors of 30 to give us a sum of 7. So we could do b plus 3 and b minus 10. The b plus 3's will cancel out, as will the b minus 3's, and that's all we can do. So we're going to get a final answer of b minus 1 over 4 times b minus 10. And in my answer key, they distributed out the 4 Just FYI, I would probably go with the first answer, but these are equivalent solutions. Not the book's best summary ever. Multiplying rational expressions is similar to multiplying rational numbers.